Hello, in this tutorial I will talk about subspaces. So a subspace is a subset of, it is a subset of Rn, okay, in n component set of vectors. So it is a subset of Rn and it is represented by S. So it has three conditions. Okay, so we find such subsets of Rn which meets three conditions. So S contains 0 vector, okay, 0 vector which with all components as 0. And the second condition is that if we have u and v as two vectors in this subspace of S, then u plus v will be also in the subspace of N. Okay, so if u and v are two vectors in subspace of N, then their sum will be also in the subspace of S. So this is called as the closed under addition rule. And the third condition to meet for the subspace is that if u and u is in the so for example, if u is in S and R is a scalar then R times u will be in S. Okay, so if we want to confirm that if some if a subset of Rn is a subspace, then we have to meet these three conditions. Okay, so let's see it with the help of some examples. Suppose we have a vector of this form a, b and 0, a, b and 0. So, and this vector is in R3. Okay, so whether if vector of this form will be the subspace in R3 or not. So for this we need to check whether this vector meet all of these three conditions or not. If any of these conditions is not met, then it is not a subspace in this R3. Okay, so for this I think, because in this case a, b are any real numbers, so if we take a is equal to b is equal to 0, a and b are 0, so then we this given vector will result into 0, 0, 0. It will be a 0 vector or null vector. So the first condition is satisfied. Okay, but it is still, we still cannot say that it is a subspace, because we need to check the other two conditions as well. So for checking the other two conditions, so we take vectors u as some value a1, b1, and then third value will be 0, and we take vector v with values a2, b2 and 0, and then we take their sum. So u plus v is equal to a1 plus a2, it will be b1 plus b2, and then 0 plus 0 is 0. So now these components a1 plus a2 and b1 plus b2 are in fact the real number. So real number plus a real number is a real number. So therefore a1 plus a2, b1 plus b2 are any arbitrary real number, and then this u plus v is of the same form as the original vector. So which means that u plus v will be in S. Okay, so if u is in S and v is in S, so u plus v will be also in S. So second condition is also satisfied. How about the third condition? In third condition, we take any scalar r which will have any real number, which will be any real number scalar, and then we multiply it with u. So it will be then ra1, ra2 and 0. So now we compare this vector with this. So we see that just like a and b are real numbers, ra and ra2 will be also real numbers of the same form. So it means that ru will be also in S. So the third condition is also satisfied. So therefore we can say that the vector of this form will be a subspace. Okay, so this is a subspace in R3. Okay, this is a subspace in R3. Okay, so we can see one more example. How about this number 2? Okay, a, b and 1. So for checking the first condition, put a is equal to b is equal to 0, and the third is of course 1. Then we will get 0 0 1. So it is now obvious that this is not a 0 vector. Okay, so we cannot get a 0 vector by any choice of values of a and b. So first condition is not met. So first condition is not met. That means it is not equal to like 0 0 and 0. So therefore is not a subspace. Okay, so when any of these condition is not met, we don't need to calculate check the other conditions. So in this case there is no need to check the other conditions since the first condition is not met. Okay, one more example. In this case we have a, b and c with the condition that a plus b plus c is equal to 0. Okay, so for checking the first condition, we take a is equal to b is equal to c is equal to 0. In this case a plus b plus c will be 0, and then if a plus b plus a is equal to b is equal to c, so we get a 0 vector. So the first condition is satisfied, so we can meet the first condition. How about the second condition? So for the second condition, we take u as vector a1 plus a1 b1 c1, okay, and v as vector a2 b2 c2, okay, and then u plus v will be a1 plus a2 b1 plus b2 c1 plus c2. So now what are these things? So these are this is of the same form as this a, b and c. a1 plus a2, b1 plus b2, c1 plus c2. Okay, but of course we need to check this condition. Okay, we need to check this condition. So that means by this condition, it means that the sum of these three components should be 0. So in this case, the first component is a1 plus a2, the second component is b1 plus b2, third component is c1 plus c2. So sum of all these components should be 0. So we need to check it. Okay, so a1 plus b1 plus c1, sorry, a1 plus a2. So the first component was a1 plus a2, the second one was b1 plus b2, third one was c1 plus c2. So we need to check it. So now we can rearrange these terms, a1 plus b1 plus c1, and then a2 plus b2 plus c2. So by this condition, we know that if a plus b plus c is equal to 0, so then a1 plus b1 plus c1 should be also 0. So this is 0 and this is 0. This means that the whole expression is equal to 0, which means that the sum of this is also 0. So it means that u plus v condition is also satisfied. How about the third condition? The scalar r we take and then multiply by u, so it will be ra1 plus ra2 plus ra1 plus rb1 plus rc1. Okay, because it will be a1 b1 c1, so ra1 plus rb1 plus rc1. So by the condition, sum of these three components of the vector should be 0. So ra1 plus rb1 plus rc1 should be 0. But how we can prove that? So we can take r as common, so a1 plus b1 plus c1. And now we know that a1 plus b1 plus c1 is 0, and whether r is a 0 or non-zero, the whole expression is 0. So this means that this is also 0, so the condition is satisfied. So it means that now all the three conditions is satisfied, so therefore this is a subspace. Okay. Yeah, so we will do one more example. The third one, okay, this is the fourth example. If we want to find it is a subspace or not, so we can say that A, B, and C, and the condition is that the absolute value of the product AB is equal to C square. So we need to find whether it is a subspace or not. So for the first condition, we take A is equal to B is equal to C is equal to 0. So we get 0, 0, 0, 0. Okay, and also we from this condition, because everything is 0, so 0 into 0, absolute value is equal to 0 square, so 0 is equal to 0. So this condition is also satisfied. So first condition is satisfied, no problem with that. But how about the second condition? So for the second condition, we take u is equal to a1 b1 c1 as before, v is equal to a2 b2 c2. Okay, so it will be u1 u plus v, that will be a1 plus b1 plus a b1 plus b2 or c1 plus c2. Okay, so this is actually with the same form as the original vector, no problem with that. But how about this condition? Okay, that means a1 plus b1 times b1 plus b2 times absolute value is equal to c1 plus c2 square. So whether it is equal or not. Okay, so we will continue this video in the next video clip.